Hello everyone. Our next practical is uh, molecular visualization tools. One among them is Rasmol. It is having a lot of application in bioinformatics and structural biology. Now we will start with the installation of the software itself. The software can be freely downloaded from openrasmol.org. Here is the website openrasmol.org, or you can go through to the Google and search for a Rasmol download, which will lead you to this page. Okay. So here is the Rasmol latest Windows installer. If you are using a Windows computer, so I am downloading it. So now software is downloaded. I'm going for installation. Okay. Now the software is installed. That can be opened by clicking Raswin in the search box. So this is the Raswin software. You can also create a desktop link if it is required. I'm just clicking on not show. Okay. So this is the Rasmol software interface. Right now I am minimizing this one. So look, here is the Rasmol terminal. There is also another window, that is a command line window. For Rasmol, it always opens with two windows. One is a Rasmol command line window, and the second one is the visualization interface. Okay, so now you have two graphical interfaces that is opened here. Okay. Now you need to open a PDB structure here. From where will you get a PDB structure? That is from where rcsb.org, for example, here. If you want to download this PDB file, you can download the file. So if by just clicking here, it will be downloaded as a tab or GZ file, which is not suitable for you. So it's better you open this one and download PDB format. So now the file is open. So this is the file. Now it is present in the downloads. Okay. So now you have a PDB file of interest. And before proceeding, I have to mention that this PDB file is a structure file. It is, I can open that for you. So I will choose another application and I will open it in a notepad, for example, or WordPad. A WordPad software, I am using it for opening. So the content of that PDB file is something like this. So there will be a header, the title, then the compound description, all are text informations. And when we come down, we can see that there is the residues that is present. And finally, the position of each or XYZ, three-dimensional coordinate positions of each and every atom that is present in the concerned structure is now represented here. So if the protein is constituted with, say, 5,000 atoms, all the positions of or XYZ coordinate positions of each and every atom is mentioned in this file. So by opening this file, the computer software can position the corresponding atom, for example, O or C, and that atom can be created or visualized by the software in that particular position in the three-dimensional space by using this coordinate file. So that's how a three-dimensional structure is created by the Rasmol software using this PDB file. So the PDB file is not an image or a video or something three-dimensional. Okay, this is not a fixed image. So this file contains all the information including the molecular coordinate positions, three-dimensional coordinate, XYZ coordinate positions of all the atoms that is present in that molecule. So now we have the PDB file that is downloaded here. I am going to open it. Open. So this is the file that is downloaded. See, the molecule is now open. So this is a large protein. And one interesting thing is that you can rotate it. So when you are rotating by clicking on the mouse and rotating it with a fixed center point, it will rotate. Okay, so the center point is not moving. But if you are clicking on the right button and move, the molecule, entire molecule can be repositioned in the window. So if you want to move the entire molecule from one position to another, then right click and move. If you left click and move, then it will rotate based on a center position. So this is how you move a molecule and visualize it in a three-dimensional space. So this is about the Rasmol. And keep it in mind that while you are doing the practical, you can take periodical screenshots of loading the molecule and making different visualizations. Okay. So the examiner may ask you to load a molecule and he will ask you to perform or show him some particular type of visualization of that molecule. So as I mentioned, this is not an image or a video. This structure is created by placing each and every atom in the molecule using the coordinate positions of each and every atom in the XYZ plane. Okay. Now you can go to the display. This is the wireframe option. So you can click on backbone. The entire display is changed to the backbone model. So only the backbone is shown and not the side chains. Now ball and stick model. Okay. Space fill model. Ribbon model. Stands. Cartoons. So I am not taking the molecular surface. It will take some time, but still you can create if your computer is good. Otherwise, it may take a little bit of resource. Yeah, my computer is a little bit faster. Still, it is taking time. Otherwise, you don't try that one. Okay. So different visualizations are there, and the basic model is this one. That is a wireframe model. So you can visualize your molecule in different ways. Okay. Now I'll show you some of the commands. Now you can go to the Rasmol commands. For example, one option is say you open a Google and click Rasmol command line tutorial. Rasmol tutorial can be opened and see what are the functions that is available, and using this one you can see what are the different commands. So these are all different Rasmol commands that can be passed into the command line. Okay, so you can see there is a lot of commands, and you can one by one you can go through that and try one by one. So initially we will try, say, Zoom is a command. Zoom 300%. So in that case, you don't have to uh, type percentage symbol. Zoom 300 and enter means the entire molecule is now zoomed 300%. Okay. So if you are interested in looking into a particular portion of the molecule uh, and zoom into a particular portion of the molecule, say I can see that zoom 400 for example, still is zoom. Okay. Now you can click on zoom 100 to restore to the original position. Okay. Now color red, the entire molecule is red. Color yellow, molecule is yellow. So you can zoom it, you can color it, or you can select it. For example, select all atoms selected. That means 6,355 atoms are there. Now select. No, okay. No. Color CPK. CPK will restore to the original color. Now the next one is select chain 1. No. Select alanine, ALA. All the alanine molecules will be selected. Now, if you change the display to spacefill, sorry, frame. So you can see that I am changing it into another display model with the sticks. So you can see only the alanine molecules which is present in the molecule is now changed to another model of display, that is a ball and stick model. Now you want to zoom it to 400 and see in the molecule only the alanine molecules were having a separate display. So it's clearly visualized. And say I want to color it, color red. So now it is red. Now I will select tryptophan and color green. So it's already changed to another color. Now I will again change to sticks. So now you see the alanine is now in red and tryptophan molecules were in green color. If you want to visualize it, the entire molecule, then you can see this is it. Okay. And if you want to restore it to the previous type, then select all wireframe and color CPK. So instead of using this command line, you can select that option from here also. So now the color, the program, the entire molecule is now restored. And there are other options like here is it. In the settings, we can have pick distance, pick angle, pick label, etc. You can select, try some of them. For example, I am zooming it to 400 percentage. Select alanine. Now I am changing the option into ball and stick, and I want to find the distance between two alanine molecules. So for which I can go for pick distance and click here. So first atom is selected and the second atom of interest here. So now it will draw a line and this is 23.52 angstrom. Okay. So this is set picking distance option. So by selecting two atoms, the molecule can be, the distance between the molecule can be determined using this option. Now there is another option, that is pick angle. For example, if you want to find the angle between of these angle, okay, this angle you want to check. So in that case, you set picking angle. Initially, click on the center atom, then side atom 1 and side atom 2. So you can see that the molecule is now that here there is a label now added. I think it is not visible. This is 24 or something. That is the bond angle here. It is mentioned there. If you want to zoom 800, okay, this is it. Here is it. The label is there. I don't know why it is not displaying. Okay. And one option is that you can select all and change it to wireframe model. So that label is there, 34.74. So likewise, you can, okay, zoom. Is too large. Okay. So this is how you pick the angle between two molecules, or you determine the distance between two molecules, or pick the angle between three atoms. So that can be done using this option from the settings. So these are some of the applications of Rasmol software, and zoom. Very colorful molecules can be created, like say select alanine. So this is all the alanine molecules. Select tryptophan. select granule, color red, select tryptophan, color yellow, display space fill. So you can create beautiful representations of the molecule in a three-dimensional space and visualize it using the Rasmol software. Okay.